Today we'll be talking about growth and decay factors. We will be able to determine a growth or decay factor based on the percentage of increase or decrease, and we will be able to use growth or decay factors to calculate future and past values. The growth factor is the ratio of new value over original value where the new value is greater than the original. And it's greater because the amount is increasing or growing. So, determine the growth factor of any quantity that increases by the given percent. So, if we want to increase by 30%, we're starting with 100%. So, we're going to add the 100% to it, which means we would want 130% of what we originally had. We're going to take that from being a percent to a decimal, which would 1.30, which would be our growth factor. So again, if we're going to start with 75%, we're going to add the 100% that we already have. So at the end, we want 175%. That would be a growth factor of 1.75. If we're increasing by 15%, add 100%. That gives us 115%. Convert it to a decimal, and we get 1.15 as our growth factor. Finally, if we have 7.5%, add our 100% that we're starting with, we get 107.5%. When we convert that to a decimal, it comes 1.075. So growth factor can always be written in decimal form, which is what we just did here. Why were all of these decimals greater than 1? Well, they were all over 100%. So, determine the growth factor for any quantity that increases by 20%. So we're going to take our 20% and our original 100%. So we'd have 120%, which would be a growth factor of 1.20. Use the growth factor to determine this year's budget, which has increased 20% over last year's budget. So we would take this year's budget, multiply it with our growth factor, and that will give us our new budget. Which would be $90,000. Remember, whenever we're working with word problems, to include units, in this case dollars, with your answers. All right, sales in your small retail business have increased 120% over last year. So still a 20% increase, so we're still using that same growth factor as 120%. Or sorry, 1.2. This year, you had gross sales receipts of $75,000. How much did you gross last year? So we know whatever we had last year times a growth factor of 1.20 is going to give us $75,000. So I'm going to divide by that growth factor. And that tells me that last year I had $62,500. For these, we're going to use a growth factor to answer the following questions. So, the cash register receipt for your new coat, which includes the 8% sales tax, totals $243. What was the ticketed price? So our growth factor, 8% plus 100, 108%, which would be 1.08 as a decimal. Whatever the coat was got multiplied with 1.08 to give us the $243. So we'll divide both sides by 1.08. And that tells us the coat was $225. The credit card receipt for your new sofa, which includes the 8% sales tax, totals $1,620. What was the ticketed price of the sofa? So same process. Whatever the original price of the sofa was, times 1.08 will give us $1,620. I'm going to divide both sides by 1.08. That tells us the sofa would have originally cost $1,500. Now for decay factors. So a decay factor is the ratio of new value over original value where the new value is less than the original. So if we're going to decrease by 30%, we're going to take 100%, subtract off that 30%, which means we'd be left with 70%, which when we convert that to a decimal is 0.70. Basically, if you think about it as like if you're at the store, something being if it's discounted 30%, you're only paying for 70% of that item. So again, 100 minus 75% leaves us with 25%. So our decay factor would be 0.25. $100 minus 15% leaves us with 85%. So our decay factor is 0.85. Finally, 100 minus 7.5% is 92.5%, which would be 0.925 as our decay factor. So if you notice, all of these are less than 1 because they are all less than 100%. So we're going to determine the new value of a stock portfolio that has lost 20% of its original value of $400. So first we need to find our decay factor. So 100 minus 20% would be 80%, which would give us a decay factor of 0.80. we would take our original value, 400, multiply it with 0.80, which means it now has $320. Voter turnout in local school board elections declined 40%. So 100 minus 40 is 60%, which would be a decay factor of 0.60. This year, only 3,600 ineligible voters went to the polls. How many people voted in last year's election? So we don't know what last year was, but we know that it changed by a factor of 0.60 to come out to be 3,600. So divide both sides by 0.60. So we get that last year there were 6,000 voters. You purchased a laptop on sale for $150. The discount was 40%. So again, 100 minus 40 is 60%, which would be a decay factor of 0.60. What was the original price? So we don't know the original. Decay factor is 0.60, and we ended up paying $150. So originally, the laptop was $250. Determine the original price of a Peloton bike that is on sale for $1,140. Assume the store has reduced all merchandise by 25%. So 100 minus 25 leaves us with 75%, which would be a decay factor of 0.75. So we want to find the original price, which was changed by a factor of 0.75, comes out to equal 1140. Divide both sides by 0.75. And we get that the bike was originally $1,520. That's all for today. See you in class.